Example 1.4.4, we're asked to evaluate the product of these two fractions. We're asked to multiply 4/15 and 25/32. And the way we'll do that is by finding the prime factorization for all four numbers, 4, 15, 25, and 32. 4 is just 2 times 2, so its prime factorization is just 2 times 2. 15 is 3 times 5, which are both prime numbers, so its prime factorization is just 3 times 5. Similarly, 25 is just 5 times 5, so its prime factorization is just 5 times 5. 32, we finally get a tree with more than one branch in it. Let's see, 8 times 4 is 32, would be one way to do it. And 8 is 4 times 2, and 4 is 2 times 2. Similarly, this 4 is 2 times 2. So we get 32 is the product of these 5 2's. In other words, it's 2 times 2 times 2 times 2 times 2. And now, if you've written all four of the numbers in this problem in terms of their prime factorization, we can figure out this problem. We can say 4/15 is the same as 2 times 2 divided by 3 times 5. And we're trying to multiply that by 25/32, which is just 5 times 5 divided by 2 times 2 times 2 times 2 times 2. And the nice thing about multiplying fractions is you just multiply straight across. That is, the numerator of our new fraction is just the product of everything up on the top here. It's just 2 times 2 times 5 times 5. Similarly, down on the bottom, it's just the product of these 5 2's, the 3, and the 5. So what we now have is a new fraction expressed as its prime factorization, and we can look for common factors to cancel. These 2's will cancel out, these 2's will cancel out, this 5 will cancel out, and I believe that's all we can do. So we can now regroup and see what we're left with. In the numerator we have just a 5, and in the denominator it looks like we have 3 2's left over, as well as 1 3. So our final answer, simplified, will be this guy. Instead of expressing the denominator as its prime factorization, we can multiply these together. 2 times 2 times 2 is 8, times 3 is 24. So 4/15 times 25/32 is just equal to 5/24.